12.3, hyperbola centered at the origin. So you have looked at circles that have been centered at the origin as well as translated. So moved off, their centers are moved off the origin. You've taken a look at an ellipse, which is an oval-shaped conic. And now we're going to look at hyperbola. So a hyperbola is created when you take a plane that intersects a double cone and you get this double U-shaped curve or a double parabola. So you have these two curves and with them you have some of the same characteristics. You still have the foci. So if we look at this, and the foci lie inside the curve. They're on the inside of the curve here. These are my foci. I have a center. My center here is at the origin, and today all the ones that we're working with will have a center at the origin. I have vertices. So I have two vertices here. Kind of like when you think of a vertices of a parabola, or the vertex of a parabola. And then you'll also notice that sometimes the curves open right and left. That would be a horizontal hyperbola. And sometimes they open up and down, and that will be a vertical parabola or hyperbola. So now we look at the specific pieces of the equation. So we have two equations. I'll highlight them. We have the x squared over a squared minus y squared over b squared equals 1. And we have y squared over a squared minus x squared over b squared equals 1. So a couple of things. They look very similar to the ellipse equation. They both are equal to 1. So you want to make sure that you set your equation equal to 1 to get it into the right form when you're graphing these. And then the other thing that you notice is we have an x squared and a y squared and an a squared and a b squared. With an ellipse, it's an addition between there. With a hyperbola, it's a subtraction because we're subtracting those differences. I kind of think about it as it's the difference of the distances, where in ellipse, it's the sum of the difference of the distances. And a couple other things. With an ellipse, the a squared was always the largest number. So you would look to decide if an ellipse is horizontal or vertical by looking at where the largest number was under. Was it under the x squared? Then it was horizontal. If it's under the y squared, then you knew it was vertical. With a hyperbola, you're kind of looking at the first fraction in the equation. So if I'm looking here, since x squared is first, I know I'm going to be horizontal. Since y squared is first, I'm going to be vertical. So my a squared is always the first, under the first fraction. And my b squared is always under the second fraction. And my a squared isn't necessarily the biggest number. So when we're dealing with ellipse, we're always thinking of the biggest number under the fractions is your a squared. Your a squared is always first. That's the difference here. A squared is always first. And you'll see as we work through a few of these. And you'll notice that in the graphs down here, we have these asymptotes, the dashed lines. So we have asymptotes to kind of help us see how our curves open. And we kind of open our curves following those asymptotes, and our curves will never cross those. So our asymptotes have this equation. If I'm horizontal, it's going to be y is equal plus or minus b over a x. And if I'm vertical, it's going to be y is equal to plus or minus a over by. And we'll talk more about the asymptotes as we graph them. And then last, we have the foci. And that's really helping you. You're going to use this equation to help you find your c value. And our c value is always the distance from our center to our foci. So if I'm looking at this equation, this right here from the center to my foci is always my C value. And so with an ellipse, it was C squared is equal to A squared minus B squared. With a hyperbola, it's C squared is equal to A squared plus B squared. And we'll work with that later on as we do some graphing. And you'll notice there's this box in the center, and we use that box to help us graph. And I'll talk about that more as we get into graphing. So here's steps for graphing a hyperbola. We're going to graph the center, and today all of our centers are going to be at 0, 0. You're going to use the x radius to plot 2 points. So that's basically, we're going to use the we're going to use when we use the term x radius and y radius, we're just looking at using the A and the B, depending on which way it opens. And then we're going to use dotted lines to draw a rectangle through the 4 points you plotted. These points will be in the middle of the 4 sides of the rectangle, not on the corners of it. Using dotted lines, draw the diagonals of the rectangles extending past the rectangles. These are the asymptotes of your hyperbola. And then draw the hyperbola curve starting at the correct vertices from the equation and follow the asymptotes. So this isn't going to make a lot of sense until we get into graphing it. Once we get into graphing it, this will make a lot more sense. These are just good steps to go back to if you get confused. So example 1, sketch the graph below, state the center, the vertices, the foci, and the equation of the asymptotes. So first thing I like to do is decide, am I opening horizontally or vertically? So I notice that I have an x squared first. So I have the x squared first. So in my mind, that means that the x squared over 16 is bigger than y squared over 49 because I'm subtracting. So that means I am going to be opening horizontally. The next thing I need to keep in mind, so my equation looks like this then. I have x squared over a squared minus y squared over b squared equals 1. So this is the equation that I'm working with. I'm working with a horizontal hyperbola. So I'm already equal to 1. I'm opening horizontally. I can see that my a squared, which comes from the 16, my a squared is always first. A squared is equal to 16, so that means a is equal to 4. My b squared is 49. So that means my b is 7. So my A distance is always going to be from the center to my vertices, and my B distance we're going to use to help us make the box. So I'm going to start out with the fact that my center is at 0, 0. And I know that we're going to get into moving that, but I don't have anything in h and a k. I don't have anything added or subtracted to my x squared and my y squared. So I have my center here at 0, 0. My A, since my x squared is first, my A is always my distance from my center to my vertices. So I'm opening horizontal, so I'm going to go over 4 in both directions. And these are my vertices. My B is going to help me draw the box. So I'm going to plot my B value, 7 up, 7 down. I can now dash in my box. I like to dash in this because this isn't part of my graph. It's just helping me find my asymptotes. So I have this box that I dash in that goes through my co-vertices and my vertices. I'm now going to use this box to find my asymptotes. And so I'm going to dash lines that go through each of the corners and the center. So here's one, and then I'm going to dash in another one. It goes through the corners and goes through the center. And so these are my asymptotes. So let me take a minute now. Well, now we can actually draw our curve. So I'm going to start at my vertices. I know I'm horizontal, so now I start at the vertices and I use the asymptotes to help guide my curve. I'm not going to cross my curve, but I'm going to approach the asymptotes. So there is my hyperbola. It's horizontal. It has a center at 0, 0. My vertices come from the distance from the center to my vertices. So I want a distance of 4. So my vertices are at plus or minus 4, 0. My foci comes from, we need to figure out the foci. The foci is going to lie inside the curves. So to find the foci, I'm going to use, kind of come over here, I'm going to use c squared is equal to a squared plus b squared. Well, I know a squared is equal to 16, and I know b squared is equal to 49. And so c squared is going to be equal to 65. So c, which is the distance from the vertice to my foci, is plus or minus radical 65. So we can go ahead, that's about 8.06. So I can go ahead and I can plot my foci. So this is my foci. So that is going to be, my foci is going to be plus or minus radical 65, 0. And my asymptotes. So and when I have a horizontal parabola, such as this, my asymptote, I just think about this as we're trying to find the slope of these asymptotes. They go through 0, 0, so I'm really just going to be y equals mx is really the kind of the equation we're writing. So we know it's going to be y is equal to plus or minus b over a x. And the reason why, if I look at this distance here, which is the rise from here to here, this distance there, I'm going to blow this up, this distance here is my b. This distance here is my a. So it's like saying rise over run, which is b over a. So it's going to be, that's for my positive, and then for my negative, it's going to be the negative b over a. So I'm going to have y is equal to plus or minus, my b is 7, my a is 4, plus or minus 7 over 4x is the equation of my asymptotes. Let's do another one here.